Hello, my name is Naeim Mahjouri, and I'm currently a senior at Auburn High School. In this presentation, I'm excited to discuss my research on designing a hybrid 3D printed piezoelectric wheel for energy harvesting and storage in electric vehicles. Currently, electric vehicles are on the rise since traditional combustion engines release a lot of harmful pollutants into our atmosphere. Electric vehicles, on the other hand, rely on more clean and sustainable renewable energy sources, such as wind and solar energies. However, a significant problem in these electric vehicles is their limited energy storage and consumption efficiency. And what this means is that these vehicles must constantly be recharged, and this is both timely and costly. So a method to approach this challenge is a photovoltaic cell. But a big problem with this is that this only works when it's sunny and clear outside. And this is not ideal in certain locations and times. Another method is electromagnetic induction charging or wireless charging. But again, as you can see in this picture, this has a very high installation and maintenance cost, since the whole road has to be taken apart in order to place these coils. Also, this is inefficient as the receiver and the transmitter must be perfectly aligned to maximize the voltage, and this is usually not the case. So the ultimate interest is to find a method to harvest energy as the wheels are in motion to power the batteries and other electrical components of an electric vehicle without relying on any environmental factors. After extensive research, I came across piezoelectric energy harvesting, and this seems to be a promising candidate. So this all works based on the piezoelectric effect. The word piezo means pressure. So if you look at this piezoelectric material right here, and something piezoelectrics have in common is their lattice structure at their atomic level. Initially, this lattice structure has a net charge of 0 in the middle, but when there's compression or tension, there is a charge distribution. The charge symmetry is altered, and now there's a net negative and positive charge that creates an electric field, and thus a voltage. Now, the greater the electric field, the magnitude of this electric field or this voltage produced is directly proportional to the force applied. So the greater the force, the greater the voltage produced. So the goal of this study is to fabricate a hybrid 3D printed piezoelectric wheel that can both harvest and store wasted frictional energy from the moving wheels in electric vehicles. The main materials I used is a 3D printer and TPU flexible filaments. Now, this was used to model the 3D printed wheel that would be used in my prototype. PZT discs are used for the piezoelectric materials, and these are highly commercial and very cheap. I also used a tablet oscilloscope, which was also very cheap, in order to measure the output voltage. These VEX parts were used to make the body of my car, and the slip ring was critical to ensure that these wires would not tangle up and rip apart as the wheel was rotating. So the main procedures I did was using these piezoelectric discs right here. I connected them all in series, and I attached it to my 3D printed wheel that I modeled using CAD software. And as you can see, these orange discs right here, they represent the piezoelectric discs, and these were all combined in series for my prototype. And this is how I envisioned before running my experiments, how I would think this model would work in the real world. As you can see in this animation, as the car is going, as the wheels are in contact with the road, there's stress applied to the piezoelectric discs, and this creates voltage to charge the batteries. Now, here's a little photo shoot I made of my prototype that I created in my garage using VEX equipment, and here's the finalized version of it. Now, here's a video I took of me in a dark room, just bringing this device back and forth with only a little bit of force applied, and I was able to produce enough voltage to brighten these LEDs to a high brightness. Now, to expand this project further, I ran a series of experiments. Now, before making the prototype, I tested the piezoelectric configuration and surface area of the discs to see the effects of the output voltage. And this would help me in the construction of my prototype in the future. Now, what I did was I connected 3 of these discs into parallel and series, and I measured the voltage produced. And for both the 20 millimeter and 10 millimeter discs, the output voltage was greater for a series. So that's why I used a series configuration instead of parallel in my device. Next, I tested speed and applied force on the output voltage. What I did was I took my prototype, put it on my treadmill, and increased the speed of my treadmill while applying different weights on top of the vehicle. And as you can see, as I increased the force applied and I increased the speed, the output voltage also increased. And here's a little video of me putting a weight on top of the prototype and putting that all on top of a treadmill going about 1 meter per second, and I'm able to almost continuously turn on these LEDs. Lastly, I looked at the time it took to charge a capacitor to about 5 volts. And as you can see, it took about 3 minutes to charge a 22 microfarad capacitor to 5 volts. Now here's 4 voltage waveforms that I produced from my tablet oscilloscope. As you can see, as I went from 0.5 to 1 meter per second, the frequency of these peaks increased. And as I went from 11 newtons to 22 newtons, the amplitude of the voltage peaks also increased. Now, in summary, this project demonstrated an innovative piezo wheel design by integrating the piezoelectric effect into electric vehicles. And by successfully creating this prototype right here, I was able to prove the real-world application of this phenomenon. Now, one of the major limitations I came across in this experiment was that since these piezoelectric discs were located on the interior of the wheel instead of the exterior, as it came into contact with the ground, the force from the ground would be absorbed, some of it would be absorbed by the tire exterior instead of the piezoelectric discs. So in the future, what I hope to do is design a better 3D printed model in order to enhance this force applied so it goes directly to the discs instead of being absorbed by the wheel itself. Also, I hope to identify new materials with better electrical properties. Currently, there's extensive research being done on man-made piezoelectric materials with high electrical properties. Lastly, I would like to thank Ms. Sharman, my engineering teacher, for allowing me to use her VEX robotics equipment to build my prototype at home. And I would also like to give a big thanks to Ms. Middleton for organizing this event for our high school. Thank you so much for your attention, and I hope you learned something useful. Goodbye.